Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and this homework is dedicated to my Year 10s as a homework stroke starter. You can be used by other students, but my Year 10s, I want you to make sure you watch this homework and have everything on here done by the next lesson back. So remember, I tell you Year 10s, don't practice until you can just get something right. Practice until it's almost impossible to get that thing wrong. Okay, so what we're going to do is I'm going to show you the starter we're going to do for the next 2 or 3 weeks, and I want you to, every lesson you're going to repeat that starter where the numbers have changed or got more difficult, and I want every time the whole class to get every single question right. So this homework is to set you up with the skills in order to answer those questions, and then we're going to repeat it for a few weeks until we've mastered everything in there. Now, it's really important in this video. There are 16 types of questions I want you to work through. It's not just about getting the answer, it's about how you show you're working and laying out your maths properly so we can build upon this and modify the starter questions over the next few weeks to get even harder. So here are the 16 questions. 6 questions on basic expanding. Another 5 questions on solving linear equations, and then some revision of areas and circumference of circles and perimeter and areas of sectors, and even quite a tricky grade A question there. So they're the 15 questions we're going to do. Okay, use this homework. I want you to take notes of how I answer all these 16 questions, and I want you to use this as sort of a reference tool when we do the starter in class for the next few weeks. It's important you write down exactly as I do and you learn the way of writing your maths and not just getting the answers. So first of all, the first 6 questions. We're asked to expand this here. Now, we're good at this in class. We would do 3 multiplied by positive x and 3 multiplied by positive 7. Now let's write our maths correctly. It's not an equal sign. We use an identity symbol, and we would say 3 multiplied by x is 3x, and 3 multiplied by positive 7 is positive 21. The identity symbol here says that the two things are the same for all values of x. You use an equal for something you're going to solve, okay, so we use the identity sign here. Okay, let's expand the following. So we're going to do 4 multiplied by 2x, and we're going to do 4 multiplied by negative 3. So we're going to use the identity symbol again. 4 multiplied by 2x is going to be equal to 8x, and 4 multiplied by 3 is 12, so 4 multiplied by negative 3 is negative 12. Okay? Right, expand and simplify. We've got 2 single brackets here, so we've got to expand each one and then we've got to collect like terms. So let's do that piece by piece. 6 multiplied by x and then 6 multiplied by positive 3, and we're going to do positive 2 multiplied by x and positive 2 multiplied by positive 7. So 6 multiplied by x, let's write it directly underneath it. Let's use an identity sign here, and then we're going to write directly underneath so we can compare. 6 multiplied by x is 6x. 6 multiplied by positive 3 is positive 18. And then we're going to do positive 2 multiplied by x is positive 2x, and positive 2 multiplied by positive 7 is positive 14. Now don't just leave it like that. Some students leave it like that and forget. Let's collect like terms. Remember, let's collect x's. So we've got 6x and we've got a positive 2x, and we're going to have a positive 18 and a positive 14. So we can collect those terms and we can say that 6x add a 2x is equal to 8x. Remember, use the identity sign. Positive 18 plus another 14 is going to be positive 32. Okay, next one. We're going to do 7 multiplied by 2x and 7 multiplied by positive 3. And then we're going to do positive 2 multiplied by x and positive 2 multiplied by negative 5. Identity symbol here. Let's write our terms directly underneath where they have arisen from. 7 multiplied by 2x is 14x. 7 multiplied by positive 3 is positive 21. Positive 2 multiplied by x is positive 2x, and positive 2 multiplied by negative 5 is negative 10. Don't forget to collect like terms. So we've got positive 14x, positive 2x, and we're going to have ourselves positive 21, subtract 10. Okay, so remember to highlight the symbol in front of the number or expression. So what are we going to get here? We're going to get ourselves 14x add 2x is 16x. Positive 21 subtract 10 is just 21 subtract 10, which is positive 11. Okay, expanding here. So how we're going to write this, what we're going to do is, I think it's the best way to do this. We do x and we're going to multiply it by everything in that bracket. So underneath here we're going to say this is identical to x multiplied by that bracket, which is x add 7. And then we're going to say, and plus positive 4 multiplied by that bracket. So we're going to write that as positive 4 multiplied by that bracket. Okay, so we're saying it's x multiplied by the second bracket and positive 4 multiplied by the second bracket combined. And now we're just going to expand. So x multiplied by x and x multiplied by positive 7, and positive 4 multiplied by x and positive 4 multiplied by positive 7. So x multiplied by x is x squared, x multiplied by positive 7 is positive 7x, positive 4 multiplied by x is positive 4x, and positive 4 multiplied by positive 7 is positive 28. Now some students think they're done there, not quite. We can collect some terms here. X squareds are on their own, x squareds are on their own. The positive 28 is on its own. However, we've got a positive 7x and a positive 4x which we could combine, and we could write this as identity sign here, x squared add 11x's add 28. Okay, let's do the exact same thing here. So what we're going to do is we're going to do x multiplied by x subtract 9, and then we're going to do positive 4 multiplied by x subtract 9. Be careful with our negative numbers. So let's have a go at that. So we're going to write this as x multiplied by x subtract 9, this multiplied by that, and then we'll write positive 4 multiplied by x subtract 9. And we're going to expand, so x multiplied by x and x multiplied by negative 9, and positive 4 multiplied by x and positive 4 multiplied by negative 9. So x multiplied by x is x squared. X multiplied by negative 9 is negative 9x. Positive 4 multiplied by x is positive 4x. And positive 4 multiplied by negative 9 is negative 36. Now we can do some collecting like terms here. The x squared's on its own, and as before, the negative 36, the number's on its own. But we can collect like terms here. So we've got negative 9x, add a 4x. So we're combining those. We're negative 9 on the number line, and we add 4. So we go 4 this way. So we're going to have ourselves x squared, subtract 5x, subtract 36. And we're done with the first 6 questions. Okay, the next question's solving for x. So we're going to lay out our work in really neatly and show every step. 2 multiplied by x, add 1 is equal to 17. So what happened to x? It got doubled, then added 1 to get 17. So to undo the process, we're going to subtract 1 off both sides. Let's have a line there. And we're going to say that this would leave us with 2x is therefore equal to 16. And then we're going to divide both sides by 2. And we're going to have x is equal to 8. Look how my equal signs are perfectly in line. That's how it should be when you're laying out solving equations like that. Let's check our work is right. If x was 8, 2 multiplied by 8 is 16. 16 add 1 is 17. I checked it and got it right. Okay, next one. Similar idea. 3x add 1 is equal to 14. I'm going to subtract 1 off both sides. To undo that, add 1. And I'm going to have myself that 3x is equal to 13. 3x is 13, so to undo that, to undo a multiply by 3, I'm dividing both sides by 3, and I get myself that x is equal to 13 over 3. Do not feel you have to decimalize this. It's absolutely fine to leave your answer as a fraction. Now, does that work? Well, 13 over 3 multiplied by 3 is 13, add 1 is 14. I got it right. Okay, next one. This is like before, apart from all I've got to do before is expand the bracket. So I could expand this bracket and I'd have something similar to question 7 or 8. So I'd have 4x subtract 4 multiplied by -7 is -28 is equal to 21. Okay, how do I undo subtract 28? Well, I'm going to add 28 to both sides as follows. And I'd get myself that 4x is going to be equal to 49. And then I divide both sides by 4. So x is 49 over 4. Okay, and that's the answer. You could check that with your calculator. If you had a calculator there, let's just actually check that. If we did 4 multiplied by 49 over 4, take away 7, close brackets, what do you get? Well, you get 21, so you know you've done it right. Okay, next one. X is on both sides and numbers on both sides. So let's deal with the number first. Let's get all the numbers together on, let's say, the right hand side. So to undo that take away 3, let's add 3 to both sides. So I'd have myself 6x is equal to 2x add 11. And then I'd subtract the 2x off both sides to bring all the x's together. So I'd subtract the 2x there and subtract the 2x there. And what would I have? I'd have that 4x is equal to 11, and then divide both sides by 4. X is equal to 11 over 4. Okay, and again we could get the calculator and check that. We could do 6 multiplied by 11 over 4, take away 3. You get 27 over 2 if you put it in this side, so 27 over 2, and 2 multiplied by your answer 11 over 4, add 8, you get 27 over 2, so it's definitely right. Okay, question 11, x are numbers on both sides but also brackets, so let's take a second to expand the brackets first, and then we're in a similar situation to question 10. So 6 multiplied by x is 6x, 6 multiplied by -1 is -6, that's going to be equal to 3 multiplied by x is 3x, and 3 multiplied by +2 is +6. Let's get all the numbers to one side, the right hand side let's say. So why don't we add 6 to both sides to undo that, subtract 6. And what would we have? Well, we'd have 6x is equal to 3x add 12. Let's take off 3x off both sides to remove that 3x there to get all the x's together. So what would we have? We'd have 3x is equal to 12, and then we divide both sides by 3, so x is equal to 4. And we should be able to check this here. 4 take away 1 is 3, 6 times 3 is 18, so you get 18 that side. 4 add 2 is 6, 3 multiplied by 6 is 18. It definitely works. And there are all the solving for x questions. Okay, next one, we've got a circle. And in this circle, we are given that the diameter is 12 centimeters, and that lets us know that the radius, which would be half of this, would be equal to 6 centimeters. So always state your diameter and radius when given a circle, so you can use your formulae. Now, the circumference of a circle is pi multiplied by diameter. So state your formula usually for 1 mark. So the circumference is going to be pi multiplied by 12. If you type that in your calculator and you do shift pi multiplied by 12, the calculator actually says 12 pi. So it's 12 pi centimeters if you left it in terms of pi. They ask for it to 1 dp. So you press the SD button, 37.699111. So C equals 37.699111. It's best to 84. So write out the whole calculator display before you round to 1 dp. So a line goes after the first decimal place. That 9 makes that a 6. We're rounding to the nearest tenth here. So the nearest tenth would be, the circumference is 37.7. Now don't forget the unit. It's a length, and we're given the unit originally of diameter centimeters, so don't forget to write centimeters. Okay, let's do area. The formula for area is equal to pi r squared. Okay, So we write our formula down. So our area in this case is pi multiplied by r squared. Now the diameter was 12, so r is 6, so we multiply it by 6 squared. Type that in the calculator and see what happens. If we do pi multiplied by 6 squared, it tells us the answer is 36 pi. 36 pi. That's in terms of pi, but it asks it to 2dp, so press that. 113.097, so area equals 113.097. Let's write the whole thing out. 3355. Now they want it to 2 decimal places here, so the line goes after the second decimal place. Okay, that 7 makes that 10. You can't write a 10 in there, so you would write a 0 and carry the 1 like that. So this would be 113.10, and the unit would be centimeters squared, because it's area, centimeters squared. Okay, now we're asked to work out the perimeter of this shape here. So don't forget, you need to be careful here when working out the perimeter. It will be the curved arc length, okay, that you'd have to work out. So it would be this arc length here, but also you'd have to add in this radius and this radius. So this shape is a sector, it's a cutout of a circle. So how would you work out the perimeter? Well, let's write down what we're going to do. The perimeter is the curved distance plus the one radius plus another radius, isn't it? So it's the red plus this line plus this line. Now how would we work out the curved distance? Well, it's a part of the circumference of the circle. So it's 60 over, so it's how many degrees you've got? 60. Out of a possible 360 in a whole circle, multiplied by pi d, which is the whole circumference. So you multiply it by pi times diameter. Now in this question, we should have started off by saying the radius was 12, so the diameter here is going to be 24 centimeters. Always state your radius and diameter. So it would be pi times 24. And we're adding this length, which is 12, and we're adding this length, which is 12. So you can get your calculator and type that in one move. Watch this. Fraction button, 60 over 360 multiplied by pi multiplied by 24, and then we're going to, we could put brackets around that to just show it's 2 separate calculations to keep it clear in our head if we want. And then we're going to add 12, and we get the following. So it's 36.566, so we say it's 36.566 37061, 37061. So we're going to round that to 1 dp, line after here, so it's going to be equal to the perimeter is 36.6, the unit centimeters, and we're done. And the last one, the area. Well, the area is actually easier than the perimeter. It's just to work out the area, it's the fraction of the circle you've got. You've got 60 out of a possible 360 degrees times by the area, which was pi r squared. And r in this case, so I'm going to rub that out, r in this case was 12, so pi times 12 squared. So all you've got to do is type that in your calculator. So 60 out of 360 multiplied by pi multiplied by 12 squared, and you get yourself 24 pi. It says 24 pi, but it asks for the answer to 3SF, so you press the SD button and you get 75.398, so you get 75.398 22369, 22369, and you want to round that to 3SF. So significant figures, there's the first, the second, the third, line after that, that 9 makes that a 4. So we would say that is equal to 75.4, and the unit centimeters squared. Okay, last question, the challenge question. Let's just read what it says. So it says that we've got ABC is the arc of a circle with centre O. So ABC, look what an arc means, is this. It's an arc, it's a part of the circumference. That's ABC. With radius 80, so the radius is 80. AC is a chord of the circle, so this thing here is what we call a chord. And it says this angle is equal to 35, AOC, A to O to C. Calculate the shaded area, give your answer to 3SF. Well, we've done these ones before, so how would you work out the shaded area? Well, this area would obviously be the area of the whole sector. If we could work out the area of the whole sector, and what would we subtract? Well, we'd subtract this triangle, so we'd subtract the area of that triangle there, because that would just surely leave me with the outside length. So how do we work out the area of the sector? Well, how much of the circle we've got? We've got 35 out of 360 degrees multiplied by pi r squared. Pi multiplied by 80 squared. Simple as that. That's that area. And you want to work out the area of this triangle, and you can use the formula for an area of a triangle is a half AB sine C, where A and B are the two sides and C is the angle between those two. So you would say this is a half multiplied by the two sides, which is 80 multiplied by 80 multiplied by sine of the angle, which is 35. So you could just type that in your calculator straight away. So you could say fraction 35 out of 360 multiplied by pi multiplied by 80 squared. And what we're going to do, we're going to subtract a half multiplied by 80 multiplied by 80 multiplied by sine of 35. Now be super careful here. I'm going to press equals. That's actually the wrong answer. The calculator has to say D at the top for degrees. So you do mode and you change it to 3 degrees, press equals again. That is the right answer. To do these calculations, the calculator's got to be in degrees mode. So you write down 119.324, 119.324, 1659, 1659. Let's do our rounding, 3SF. The first significant, the second, the third. Line goes here. That 3 doesn't change it. So we would write that the area is equal to 119, and the unit would be not centimetre squared in this case, but metre squared. And we're done. That's all the homework. Make sure you understand those 16 questions, how to do them, have a revision sheet or an A4 page that goes through them so you can use that to help you when we're doing the start of the next few weeks. Thanks loads for watching.